So economization of a power series is nothing but conversion of a series into another in such a way that the new series converges rapidly. So we'll see few examples, then you'll understand. But basically, if you are given any power series, so if you have a power series in the form of f of x, which is equal to a naught plus a1x plus a2x square plus up to so on plus an x raised to n, and the range for this x is in between, so this x belongs to -1 to 1 interval. So if you have this power series where a0, a1, a2, an are the coefficients of x, x square, x raised to n, so we have to use the Chebyshev polynomial to convert this given power series, and the conversion is like f of x equals to some another constant b naught plus, now if we convert this x into t1 of x, then we'll get another constant, so we'll name that as b1. So b1 t1 of x plus b2 t2 of x plus up to so on plus bn tn of x. Okay, so we know that value of x is nothing but t1 of x, x square is 1 upon 2 something. So after substituting that, we'll get the equation in terms of t1, t2, tn, and then after collecting the like terms of t1, you will get certain coefficient as b1. When collecting the coefficients for t2, will get as b2. It is in the general form. So this is nothing but the economization of the given power series. So let's see one example. So suppose we are given sine of x, which is equal to x minus x cube upon 6 plus x raised to 5 upon 120 minus x raised to 7 upon 5040. Okay, so looking at this power series, what we come to know, what comes in our mind is 1 upon 5040. So as the denominator is much bigger, we can say that this entire ratio is equal to 0.000198. So this is a very minute number, and if we multiply any number, in this case if we multiply it by x raised to 7, then we will get a certain number which after adding to the series will give a change in the answer at the fourth place after the decimal point, which is a very minute change. So instead of considering this term, we can avoid this term and just take into consideration as sin x approximately equal to x minus x cube upon 6 plus x raised to 5 upon 120. So this is the first approximation after excluding the term x raised to 7 upon 5040 because of its minute nature. Now what we are going to do is we will use the Chebyshev polynomials. So while using this, what you'll get is, now sin x as it is equals to, what is the value for x? It is t1 of x minus, now 1 by 6 common outside. Now instead of x cube, what we can write is 1 upon 4 into 3t1 x plus t3x plus 120 outside into, so now into 1 upon 16 into, so I'll write this bracket here, so this into 10t1x plus 5t3x plus t5x. Okay, so now solving this, what you'll get is t1 of x as it is minus, so now this will become 3 2s are, so 1 upon 8 t1 of x minus 1 upon 24 t3 of x plus 112 into 16, so it will become again, so this 10 will get cancelled, 1 upon 192 t1 of x plus 1 upon 384 t3 of x plus 1 upon 1920 into t5 of x. Okay, so then collecting the t1, t2, t3 coefficient, we will get collecting 1 minus 1 upon 8 plus 1 upon 192 t1x plus 1 upon 384 minus 1 upon 24 t3x plus 1 upon 1920 t5 of x. So this will give us certain value, and again if we observe, then again 1 upon 1920 is again in this denominator is larger, so we'll get this entire value as 0.00052, and this, because of this, it will produce only a small change in the entire equation, so again we can neglect that. So what you'll get is, so this, solving this, you'll get 169 upon 192 t1x minus 5 upon 128 t3x. Okay, so we know value for t1, that is x, so 169 upon 192x minus 5 upon 128, so instead of t3x we can directly substitute 4x cube minus 3x. So again solving this, we can finally say that sin x is equal to 383x upon 384 minus 5 upon 32 x raised to 3. So this is the reduction of sin x or the given power series, and this is known as economization of the given power series. So let's see another example. So a second example, economize the power series sin h x, which is equal to x plus x cube upon 6 plus x raised to 5 upon 120 plus x raised to 7 upon 5040, and it is on the interval -1 to 1, and we need to allow the tolerance of 0.0005. Okay, so now first of all, again after seeing this power series, we can see that 1 upon 5040, again this is very small quantity, which is equal to 0.000198. Okay, so we can neglect this entire term. So what we get is sin hx is approximately equal to x plus x cube upon 6 plus x raised to 5 upon 120. So this is the first reduction. Now we again have to convert this given series in terms of Chebyshev polynomial. So we have sin hx, which is equal to, instead of x it is t1x plus 1 upon 6 and x cube, so 1 upon 4, so 1 upon 24 into 3 t1x plus t3x plus 1 upon 1920 into 10 t1x plus 5 t2x, sorry, t3x plus t5x. So solving this, what you'll get is t1x plus 1 upon 8 t1x plus 1 upon 192 t1x plus 1 upon 24 t3x plus plus 1 upon 384 t3x plus 1 upon 1920 t5x. Again, after observing this, what we can say that 1 upon 1920 is again a minute term, which is equal to 19120 equals to 0.000520. So we are allowed to reject this. So again you'll get sin hx equals to, solving the or getting the like terms together, you'll get 217 upon 192 t1x plus 17 upon 384 t3x plus 1 up. So again you have to neglect this, so no need to write the terms for t5x. So now substituting the value of t1x, so we'll get 217,192 into x plus 17 upon 384. Instead of t3 you can write 4x cube minus 3x. So solving this, final answer you'll get 383 upon 384x plus 17 upon 96x cube. So this is the final answer for sin hx. So now the next point is orthogonality property of Tn of x. So our next point is orthogonal property of Tn of x. So if you have a polynomial Tn of x, then first of all consider integral 0 to pi Tn of cos theta into Tn of cos theta d theta, which is equal to integral 0 to pi. So Tm of x is equal to, so it will become cos m theta into cos of n theta d theta. Okay, so now we will have the conditions for m and n. So if m is not equal to n, then we'll have integral 0 to pi cos m theta into cos n theta d theta, which is equal to, so for is equal to 1 upon 2 integral 0 to pi cos of m plus n into theta plus cos of m minus n into theta d theta. The value for this is, because if you consider this as a and this is as b, then cos a plus cos b, you'll get 2 into cos of a plus b by 2 into cos of a minus b by 2. So m theta plus n theta plus m theta minus n theta, so you'll get 2m theta upon 2. So 2 will get cancelled, so you'll just get m cos m theta. Similarly you'll get cos n theta as this, and this 2, it goes in the denominator place over here. So now we have to solve this integration 1 by 2 as it is. Now integral of cos m plus n theta, that is sin m plus n theta upon the derivative of m plus n theta, that is m plus n. Similarly, plus sin m minus n theta upon m minus n, it goes from 0 to pi. So substituting the values for theta, you'll get 1 by 2 into sin m plus n theta So now instead of sin m plus pi theta, so now if we substitute as pi, then any multiple of sin n pi, that is sin n pi, is again equal to sin pi. So instead of writing m plus n pi, you can directly substitute as sin pi upon m plus n minus sin 0 upon m plus n, plus again similarly here, instead of writing sin m minus n pi, you can directly write sin pi minus m upon m minus n minus sin 0 upon m minus n. So 1 upon 2 into sin pi upon m plus n plus sin pi upon m plus n minus sin of 0 upon m plus n plus sin 0 upon m minus n. So sin pi and sin 0 values are 0, so 1 upon 2 into 0, which is equal to 0. So if m is not equal to n, then the dot product of cos m theta into cos n theta is equal to 0. So we'll see the next case. This was case first. Now we'll see the case second, where m is equal to n, but it is not equal to 0, that is any non-zero number. So 0 to pi cos of m theta into cos of n theta d theta is nothing but integration 0 to pi cos of m theta whole square d theta. So instead of 1 cos square m theta, you can write it down as 1 plus cos 2 m theta upon 2 d theta, which is equal to, so taking 1 by 2 outside, integral 0 to pi 1 plus cos of 2m theta d theta, so which is equal to 1 upon 2 theta 0 to pi plus sin 2m theta upon 2m, it goes from 0 to pi. So substituting the values for pi, so for theta, you'll get 1 upon 2 into pi minus 0 plus sin pi, 2 pi is again 0, so 0 minus 0. So final answer is pi by 2. So if m is equal to n, then we will get the dot product of cos m theta and cos n theta as pi by 2. So now we'll see the third condition, that is if m is equal to n and it is equal to 0. So if m equals to n equals to 0, then again integral 0 to pi cos of m theta into cos of n theta d theta, that is nothing but integral 0 to pi cos 0 is 1, cos again this 0 will be equal to 1 d theta, which is equal to integral 0 to pi d theta, theta from 0 to pi, which is equal to pi. So if m equals to n and it is 0, then the value for this dot product is pi. So what we can conclude is integral 0 to pi Tm of cos theta into Tn of cos theta d theta equals to 0 if m is not equal to n, equals to pi by 2 if m equals to n but it is not equals to 0, and it is equal to pi if m equals to n and it is equals to 0. Okay, so now if we consider this cos theta as x as we have considered it before, so what we can write as sin square theta plus cos square theta equals to 1. So this sin theta can be written as square root of 1 minus cos square theta, and we know that cos theta is x, so instead of sin theta we can write it as 1 minus x square. Okay, so now if we consider this cos theta equals to x, then the derivative of it will be minus sin theta, which is d theta, which is equal to dx. So to find the value of d theta, we'll get dx upon minus sin theta, and we know that sin theta equals to square root of 1 minus x square. So instead of sin theta we can substitute it, so dx upon square root of 1 minus x square. Okay, so now if theta equals to 0, what we'll get is if cos theta equals to 0, then x equals to 1 because cos 0 is 1, and if theta equals to pi, then x equals to minus 1. Therefore, substituting the values for this, so integral limits will change from 0 to pi to 1 to minus 1. Instead of cos m theta, we can write Tm of x into Tn of x upon square root of 1 minus x square and minus sign dx, which is equal to integral minus 1 to 1 Tmx into Tnx upon square root of 1 minus x square, because we have just interchanged the limit, so negative sign will get cancelled, and we can write this values as 0 if m is not equal to n, which is equal to pi by 2 if m equals to n but it is non-zero, and which is equal to pi if m equals to n, which is equal to 0.